All for coming. Greatly appreciate it. My name's Nikki Krueger and I'm the Building Science Manager for Therma-Stor for our residential line and light commercial products. Today we're going to be talking about really how building codes and our building practices are changing. Also how some of our standards are driving the need for dehumidification like ventilation. And Ron's going to be jumping in later on more on the light commercial side and applying dehumidifiers for those applications as well. So just a little bit of background. The company is Therma-Stor. We are located in Madison, Wisconsin. That's where our factory is, where we manufacture our dehumidifiers. We invented whole house ventilating dehumidifiers in the mid-90s. There's a gentleman named Ken Gehring who invented these. He's around 80 years old now, and if you ever go on a forum called HVAC Talk, he's known as Teddy Bear on there. He will answer any moisture questions you have, and what's great about Ken is his honesty and the capability of our dehumidifiers, and he will probably be the first one to tell you when a dehumidifier is not going to fix a situation, because we really want to make sure when you're applying a dehumidifier that it's going to be successful. And there's lots of things we need to take into consideration before doing so. So we also invented the first horizontal crawl space dehumidifiers, which is our Santa Fe brand, so basement and crawl spaces. Quest is our commercial line. If anybody's working in what we call agriculture dehumidification, so grow houses of any sort, we manufacture dehumidifiers for those applications as well. Phoenix is our restoration line. We're probably one of the largest manufacturers of restoration equipment. So when there's hurricanes or water losses, anything like that. And what's important about mentioning that is a lot of the components used in our commercial dehumidifiers are used in our residential dehumidifiers. So, and that's why we can offer a 6-year warranty on our dehumidifiers as well. So just some basic terms, which I never assume anybody knows anything, and I just want to, or everything, and I want to make sure that we're all on the same page. So sensible load is the temperature. Obviously what the thermostat is trying to get to is that sensible load, and then the latent load is the moisture, and that's really what we want to address with the dehumidifiers. So a pint's a pound the world around. So if we say a dehumidifier is 70 pints or 70 pounds, it's the same thing. It takes about 1,000 BTUs to remove a pint of water, which when we start getting into our tighter constructed homes, we really might have to take in that consideration of the heat from a dehumidifier a little bit more. And then 1 CFM in is 1 CFM out. And really, if you're in a humid climate, 1 CFM out, 1 CFM in, and we really, when we're using exhaust-only ventilation or that kind of strategy, we really need to think about where we're sucking in that other CFM that we're exhausting. So hot goes to cold, wet goes to dry, high goes to low. So in our mixed humid and hot humid climates, we really need to be thinking about our house is constantly being bombarded with moisture, with heat. If we're using exhaust-only ventilation, we're going to be bringing in even more of that. So really important to know, obviously in the wintertime, if you're in a colder climate, it's the opposite, right? Our houses are like a hot air balloon and everything is trying to go out. So relative humidity is relative to the temperature. So what's really confusing is a lot of our organizations like ASHRAE, American Lung, Building Science Corp, everybody's telling us to try to stay in this humidity range. But what's really important is you can't stay in that humidity range without actually understanding what the temperature is as well. So if it's 50 degrees, this amount of water is 85%. As soon as we heat up that air, that amount of water is only 43%. So relative humidity obviously is relative to the temperature. Relative humidity is important when we look at the contents inside of a house. So the carpet, the mattress, the couch, All of that is constantly absorbing that relative humidity inside of the house. And then we get into dew point, which is really important because when we start seeing condensation on surfaces, that very quickly can lead to microbial growth. So dew point is very important in our industry. I think more and more we're hearing that we would all like to go more by dew point instead of relative humidity, but homeowners don't understand either one of them really, but they can go out and buy that little relative humidity sensor, so it makes it easier to try to talk in their terms. So if the dew point is above the surface temp, condensation will occur, and if you keep it below, so closets, always an issue, right? We get a lot of microbial growth in more humid climates, in closets, in corners, those kind of areas where we're not getting a lot of air movement, and potentially we've got hot air on the outside, cold air on the inside, and we start hitting dew point in those crawl spaces. Anybody here working in crawl spaces? We deal with a lot of condensation issues because we've got water pipes and duct work. Crawl spaces is a big one also. So this is a dew point map. This was actually last October. And a lot of times when you're working in the dehumidifier business, everybody's like, oh, you know, people in Florida, they need a dehumidifier. It's so humid down there. And the reality is there's certain times of the year down here we're not running the air conditioning as much, but a lot of times the air conditioning in our homes are running quite a bit down here to be able to remove that amount of moisture. But last October, you can see, I mean, all the way up into the Midwest and the Northeast, we had some pretty high dew points, and most likely we're not running any air conditioning the farther north you go when the dew points are that high. So dehumidifiers really shine in shoulder seasons, and down here in Florida, which could be, you know, November is a shoulder season down here. Nighttime, when the air conditioning isn't running as much, that's when we really want to apply. We want to set up our air conditioners to run, to remove as much water as possible. Let it do its job, but let it get to that temperature set point. Don't extremely overcool, and then let the dehumidifier kick in to get you to that set relative humidity. So this is when we're talking about dew point and hitting condensation. This is actually a project that Teddy Bear, Ken Gehring, drugged me into in Northern Virginia. And these were lead-built townhouses. And this is the third floor master bedroom. And the homeowners, or the townhouse owners, actually ended up cutting out the ceiling because of the condensation, and it actually had rotted out the drywall on the ceiling. And what happened was they were having high moisture, and so they called their HVAC contractor, and the first line of defense for the HVAC contractor was to turn down the fan on the AC system. And so he turned down the fan on the AC system to run longer, run colder, and this ductwork was wrapped, it was insulated. But what we ended up figuring out is, you know, when they insulate the ductwork and they go to the top, it always isn't sealed perfect around that ductwork. So we had they had cut out here in the rim and band, and we pulled out the fiberglass batting, and you could see it was black. So we knew we had a lot of infiltration coming into the ceiling cavity, and we had hot, warm air coming in, and it was hitting on that ductwork where it wasn't insulated perfect. And actually, when they removed that insulation, it was just water coming down. So while we want to set up the air conditioner to remove as much water as possible and to run without overcooling too much, we also have to keep in mind when we're running, where could air be coming in? We could have a super tight house. We could be less than 3 ACH 50. You still have holes somewhere, and you don't know always where all those holes are. So you've got to be careful when you're running. And they were running continuous exhaust ventilation as their ventilation strategy, which if you are in a mixed humid, hot humid climate, highly caution against running continuous exhaust ventilation as your ventilation strategy, because you are sucking in every CFM going out, you're sucking in from somewhere and you don't know where you're sucking in from. So it's not conditioned, it's not filtered. So we stopped the continuous ventilation. We ended up putting in a whole house dehumidifier to also try to keep this ductwork a little bit warmer when the AC was running, to prevent this. But we are seeing more and more of ductwork that is condensing with this overcooling strategy. So we have to keep in mind what potentially could happen when we use that strategy. So Brian Orr, causes of relative humidity. Did anybody see this article that Brian did? It's a really good one. Causes of indoor relative humidity, low heat loads. So the tighter our houses are getting, if you live in a state that is 2015 code or newer, you are in a low load building state. You might not think it is, but you are building tight houses. So a lot of builders out there say, you know, I'm not building low load homes, I'm just building the code. Well, you are building low load homes if you're in a state, Maryland, there's several of them now that are on that 2018 even. So that gives us short runtime equipment on our short run times on our equipment, and we also have a lot of system oversizing naturally by manual J. Manual J oversizes by at least 15%. Typically, we oversize beyond that because we don't want the callbacks. We have a lot of external humidity drivers, a high outside, internal, people. Houses work till you put people in them. Poor or no spot ventilation. They got to use that ventilation, so we put it in, but you know, homeowners actually have to use it. One of the things when I'm talking to homeowners about using their exhaust ventilation in their bathrooms is it needs to run 20 minutes to a half an hour after you're done with your shower. So, you know, we go in, we flip it on, we leave the bathroom, we shut it off. We really need longer run times on our exhaust ventilation to get that spot ventilation in that area. Whoops. So our HVAC systems are getting more energy efficient, and to maximize that energy efficiency, we're having high sensible heat ratios, which we'll go into, but basically they're not removing as much water as they used to in order to be very energy efficient getting to that thermostat setting. Not enough dehumidification capacity on our HVAC systems, low space temperature, and then again, relying only on the air conditioning system to dehumidify. Again, we want to maximize it, but we can't rely on it to get us to that 50-55% relative humidity set point all the time. Oh, excuse me. So for lower humidity home, you want longer run times. That's really hard to convince some homeowners when they bought an energy efficient house and they've been sold on that. And then you tell them that we're going to have to slow that fan down and run longer times in order to dehumidify. The whole goal of that energy efficient home was for shorter run times. We need a colder evaporator coil. So again, you're selling them a high efficiency air conditioning system at a high evaporator coil temperature, and then we got to get that temperature down on it, which is going to cost them more energy. Less moisture coming in from the outside. We need less moisture being generated inside. That's always challenging. People aren't going to change their ways typically. Higher indoor temps, which if you use a dehumidifier to control the relative humidity, you should be able to set that thermostat at a higher setting and feel more comfortable. So potential energy savings there. Extra water removal with a dehumidifier and making sure that they're using that spot ventilation. So people generate moisture, about 1/4 pound per hour. So a family of 4 is about 2 pints or pounds of moisture an hour. So we need to make sure that we're taking that into consideration. So we can design for this. we, in our manual J's and everything that our equipment sizing, we can design for this. What we can't design for is things like this. So this was about a 400 square foot apartment in out by Virginia Beach in Virginia, and this lady was so excited to show me her QVC clothes drying hangers. And I think this project had 2-ton units, HVAC equipment on these units. So when you walked in, when it was running, I mean, it just blew you over, but it didn't run very long. And so we had a lot of microbial growth in these apartments. And then we have situations like this. We have, whether it's legalized plant growing or illegal plant growing, we do get a lot of these situations as well. This is hard to design for, and we can't control what people do in their homes. So we've moisture balancing. I don't know, about 2 summers ago now, I know in the mid-Atlantic, lots of rain. Lots and lots of rain, high humidity. Buildings that had never had problems before actually hit what we called, the dripping point. It was that tipping point where we just had a lot of buildings, a lot of homes with moisture issues. So, it's really important that we try to keep our houses balanced. They can absorb so much moisture, but there's going to come a point that if we don't address it correctly, that we're going to have that problem. So I've got this video where wet, dry, wet, 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 and then we've lost the battle at that point. So, so low sensible load buildings. Has anybody heard of the new ACA manual LLH? No? Okay, yep. So ACA has recognized that basically our houses are getting tighter. Our building construction practices are changing. I was a member of the committee that helped on this, and basically it's a guide that if you already are using Manual J, Manual S, Manual D, that this is a guide on how to size and what equipment you should be using based on climate zone to size equipment for these tighter houses. So it's a guide. It's not meant to replace any of those. And basically it says in this guide, if you're building in a state that's 2015 IRC code or newer, you're building a low load home. And low load, basically it's low sensible. That's why I kind of have a problem with the title of this, but it's low sensible, not low latent. So we have continuous insulation, which is low cooling load, airtight construction, which is driving down our cooling loads, optimized windows and shading, mechanical ventilation is actually adding to our sensible and our latent potentially. Here it says ducts and conditioned spaces is obviously driving down our cooling load. It says it doesn't affect the latent load, but I would argue that it would actually be driving up our latent load, because when you put ducts in conditioned spaces, our AC isn't going to run as long and remove the moisture that it used to. Ducts, when most of them were at 30%, you lost 30% of your cooling and heating through the ducts. Well, now you're keeping it in a conditioned space, which means less runtime on the AC, which means less water removal as well. So basically, this manual is saying that if you're designing for these low load homes or newer code built homes, you're starting at about 1,500, a ton per 1,500 square feet, which is really going to be hard for a lot of us in the industry to design to comfortably and understand that. But it's where our homes are going. And there's a lot of challenges when you start designing for homes at, a ton per 1,500 square feet. We got to think about air distribution and not having stagnant air. We have to think about air filtration, ventilation throughout that entire home. So there's a lot of challenges that come in when we start building to these tighter homes. So there's a lot of organizations out there. If you're not just building to code, but you're building to these tighter homes that have a lot of programs that basically want us all, no matter what that program is, everybody wants to be more energy efficient. We want less runtime on our HVAC equipment. That's the goal. But there's a lot of challenges, obviously, that come with that. One of the things that we typically use now is higher SEER equipment. And we'll go over to, how that higher SEER equipment is actually causing us some more moisture issues as well. We have a lot of partial load and no load times, even here in Florida. There's a lot of homes that are seeing mostly partial load run times, even in peak season, because they're being built so energy efficient. And more efficient, sensible cooling at the expense of latent removal. So I don't know in your areas, I know everybody's from kind of all over the place, but I know like the NGBS has a program for green building, and even Energy Star. Net zero is a big one that's coming down the pike, where you need to look at the Indoor Air Plus program. But most of these standards in them have the criteria to put in equipment, HVAC equipment, that will keep it at 60% relative humidity or dedicated dehumidification. And what they're coming to us now, Indoor Air Plus has come to us and said, maybe this using the HVAC equipment to keep us at 60% isn't always the right solution all the time, because what we're doing is overcooling to try to keep us at that, which again, we've saw some condensation and we have comfort complaints when that happens as well. So maybe we should be recommending more dedicated dehumidification in certain climate zones. So low loads vary, but sensible loads vary, but latent loads pretty much stay the same. This is some data logging we did in Texas. I think it was in the Houston area. And as you can see here, this is our outdoor temperature. So, morning we're at about 74 degrees. This is our outdoor relative humidity. And so obviously this varies from 70% to when we heat up in the middle of the day, but what's not changing is our dew point. Our dew point is still staying the same throughout the day, regardless of what the temperature is. And this is why we say we really need to focus more on what those dew points are than focusing on the relative humidity. So we can have 90% to near zero sensible loads in one day, but the moisture is still staying the same. And this is our ventilation there. This is what we're bringing into our home, and why we need to really think about controlling humidity all day and not just when our AC is running at peak load or partial load. So there's the need for dehumidification is significant. Of course, we've got health. Health is a big one and becoming more and more. We're seeing that a lot of homeowners automatically think when they buy a newer home that it's going to be energy efficient. But what we're seeing from statistics, and I have a slide in here, is homeowners want a healthy home. So a lot of builders are going to marketing healthy homes instead of just an energy efficient home. And all these organizations, again, everybody's got this range of relative humidity, but not really talking about temperatures. So if you go to our website, we actually have a link to a This Old House segment, Ask This Old House. And we did a segment in New Orleans in July. And I was down there for most of the shoot, except for the very end. I had to leave. And of course, that's when they talked about the controller and where to set the relative humidity. And so I'm watching the segment as it's airing, and the homeowner's like, well, what should I, set that at? And Richard, who is, I think, from Minnesota or somewhere up north, goes, I like to keep it at 35%. And I went, oh, I mean, if you can get to 35% in the winter in a northern climate, you're happy, right? I mean, that's like, you're comfortable. But to try to get that in New Orleans in July, I'm like, oh, it's just going to run all of it. So I had to talk with the homeowner and said, well, let's aim for 55%, and I think you'll be pretty happy with that. But again, that's the problem with this relative humidity is homeowners, I saw something that I need to have 50%, and they think they need to have 50% all year. And depending what climate zone you're in, that's not true. We need to know the temperatures. So here's what ASHRAE puts out there for the health, and this is really important, and I'm sure you've seen this. Everybody's using it, but we really want to try to keep in this optimum zone of relative humidity. And a lot of this, especially when we look at chemicals, and a lot of people are having more and more immune deficiencies and chemical sensitivities. And it is proven that the higher the relative humidity, the faster our products in our home off-gas. So if you can keep the relative humidity around 50 to 55%, they off-gas slower, and typically will help minimize that. Ken, Teddy Bear, was involved when the Chinese drywall was going on down here in Florida. And what we figured out was that the higher the relative humidity, the more off-gassing we got from the drywall. So they actually know that the drywall went up north, but it's harder to find because we don't have the relative humidity for as long as period of time as down here in Florida. Unfortunately, a lot of homeowners, of course, were not, even as a mother, I would not accept, well, if we put in a dehumidifier, you won't get the off-gassing from the drywall. At that point, people were like, just get that stuff out of my house. But we did know, that was one of the things that we figured out is even formaldehyde, if you control the relative humidity, that usually minimizes a lot of the formaldehyde levels as well. And here's one of those statistics we talked about with healthier homes, that homeowners are willing to pay more for a healthier home. And actually builders, and some of the data that supports this as well, as they sell faster when they promote that the home is healthy. So here is our manual J, using the manual S calculator. And this is industry best practices right now, right? So we're running our manual J's, we're picking equipment using our manual S. So this is, again, Houston. We have an indoor cooling design of 78, which is high. That probably should be a little bit lower. Our outdoor cooling temp at peak is going to be 93 degrees. And we're aiming for 50% relative humidity. So manual J is always trying to get you to that 50% relative humidity level, typically. So we've got 4 people in the house. We've got a CFM of fresh air of 71. And this is going to give us our total cooling load, with the sensible being 29 and the latent being 71. We know more and more with our building practices that these numbers are not that drastically different, that we're actually moving closer to our sensible and latent loads being closer to the same number. But I just took the ACCA Manual J class a couple months ago, and there was a lot of talk still of oversized because you don't want that callback in July and we got to be very, very careful with our oversizing with our new construction practices. We really do want to right size as much as possible, depending on your homeowner, and you might even want to undersize a little, but that's really hard because we don't want those callbacks. But the reality is we need that AC to run.
What percentage over you would call oversizing?
Well, the software does it automatically 15%, which most people don't know. And then a lot of contractors then add another 15%. So, we could be 30 to 40% oversized. So if you really just go with what the software gives you, you're automatically 15% oversized. And that's these calculations are peak load. Do you know how often our houses run at peak load? What percentage of the time? 1%. 1% of the time we're running at peak loads, and that's what we're designing for. So that's where we have to be really careful than really oversizing. And We're just not going to get the latent removal we should be getting from our air conditioners. I mean, that piece of equipment's already in there. We want to maximize that. But we also know that it's just trying to get to that temp, and you can have an RH on it, but again, you know, you set it to that RH, it's just going to overcool, and so it's challenging. It's very challenging, and we're going to talk about some of these other ways to dehumidify using other equipment. So again, the air conditioner is just trying to get to that temperature setting most of the time. 70 and raining, not going to happen. I mean, they're not going to run it. That's our days when we have the most challenge with humidity, is that 70 and raining. So this is from ASHRAE. Typically, before you get effective dehumidification, you need at least 14 minutes of runtime before water starts going down the drain. A friend of ours that is a building scientist, he monitored, I don't remember how many multifamily apartment units. I think it was in Tennessee 2 summers ago, and the average runtime was 7 minutes on those systems, because they're so oversized, especially for multifamily. So variable speed slows the air conditioner fan down, like we talked, makes smaller amount of cold air. This is a register that was here in Florida. We start getting condensation on registers when we get that really cold air. And again, you know, one speed of variable is off. So 70 and raining, the homeowner's walking by, they're feeling cold air coming out of a register, they're most likely going to shut it off. Ductless mini splits, great technology, does a really good job of conditioning small spaces very quickly. Dehumidification mode is typically a timer-based system. So you're going to hit dehu mode, and then it's going to run for a period of time based on a timer. You can get into a lot of trouble very quickly if you're using that mode. We have a great partnership with Mitsubishi. We do a lot of their builder trainings together. They do not encourage their builders and contractors to count on that dehumidification mode, especially in higher performance homes and buildings, because you will get in trouble with that. Have you ever seen a condensate line on a ductless mini split? It's about the size of a pencil. Not a lot of water going down those. All right, so high energy or high SEER AC systems. They have larger coils on these systems. So they're very efficient at getting to that cool temperature, or that set point on the thermostat. These coils hold about a pint or a pound of moisture on the coils. So per ton. So if you have a 5-ton system, you've got 5 pounds or pints of water on the coils. They don't get as cold as the older AC systems, so a little less water removal going down the drain. And they get a higher SEER number by running the fan once the compressor shuts off. So if you're in Arizona and you want evaporative cooling, this is a good strategy. If you're in Florida, you probably don't want all that water that potentially 5 pints or pounds of water that's on that coil. You don't want that re-evaporated back into your house. And it can increase the relative humidity back up by about 10% if we do that. So there is an option on those systems not to run the fan. Please set that up if you're in a hot, humid climate or a humid climate. But you lose some of that energy efficiency that you were sold or you're selling your homeowner as well. But it's not much. But please, please, please be aware of this, because it has led to definitely some issues. So the sensible heat ratio is the dehumidification effectiveness of the air conditioning. So basically, how effective is that piece of equipment at removing water? Really, really need to be looking at this more and more when you're picking your equipment, is what is that sensible heat ratio of the equipment. So what's interesting about this is typically the higher the sensible, or the SEER, the higher the sensible heat ratio. So this 33 SEER system is at 0.96. You really want to be at about 0.74, I think is what ASHRAE, 0.77 or lower in order to get the maximum water removal. That system right there isn't removing much water at all, which is fine. Just, choose it if that's what the homeowner's really after, with the understanding that you're probably going to have some sort of dedicated dehumidification.
Are those all ductless units?
Those are all ductless units.
Carrier numbers?
Yeah, those are Mitsubishi. Yep, Mitsubishi numbers. So this looks like a lot here, but I'm gonna break it down for you. One of our colleagues built a very energy efficient house in Raleigh, North Carolina, and he's using ductless. A lot of people in here using ductless? Some, not a whole lot, okay. Some caution when doing so. So the orange here is our latent, the blue is the sensible, and then the gray is the total cooling. So we're gonna break this down, this little section right here. And this is what it looks like when we break that down. So let's take this right here. We've got 10 p.m. See, how much do we have here? We've got about a 20, we have a 5-minute runtime there. Yes, we've got we've got a 4-minute runtime here on this ductless heat pump performance. So with 4 minutes of runtime, we're getting a sensible heat ratio, or a sensible heat ratio of 1.52, which is not even really possible. And the reason that we get that on here, as you can see, our sensible and our latent are almost the same, is because when it shuts off and that coil's loaded, we have no water going down the drain in 4 or 5 minutes of runtime. So all that water on the coil is actually going back into the house. So we're getting cooling with humidification when we have those short run times. So we've got to get our equipment running longer periods of time in order to get more of a, we'll look at some data here, more something looking like this, where I think we have 12:29 we have almost 45 minutes of runtime on this ductless heat pump in the middle of day, which gives us, the sensible heat ratio of 0.65. So we're getting really good water removal. We really need those longer run times. So even if, it doesn't have to be ductless to not be removing the water we need. If we have a tight house and an oversized system, we have the same thing going on. We're not getting the long run times we need for that to go down the drain. Charlotte, North Carolina, we've got data pulled for all over the country. If you're interested, after I go through this and explain it a little bit more, that we can help you. So this is an 1,800 square foot house with 4 people in it, built to code in Charlotte, North Carolina. And what we did is there's a software program out there that's free called BOPT. I think NREL offers it. And you can go in and put in different housing and scenarios and different equipment to get data that looks like this. So this red line here is a 14 SEER system. Blue line, the lighter blue or darker blue, is a 14 SEER with a 70 pint dehumidifier. The yellow is an 18 SEER. The lighter blue is 18 SEER with a 70 pint dehumidifier, and then the red is a 22 SEER system. So from January, so basically January through February, and this is our indoor relative humidity. And what you can see by using the different systems is kind of out of range or high you're going to be if you're counting on those systems to control your relative humidity alone. So if we're using a dehumidifier and we set it at 55% relative humidity with even a basic 14 SEER system, we're going to have better control and probably better comfort in that house than if we were trying to use 22 variable speed system to try to control that relative humidity. Because no matter, even using variable speed, you have to have a load in order to remove that water. And if there's no load, no sensible load, it's not going to run what you need it to in order to remove the humidity. Does that make sense? So we have these for all over the country. If anybody's interested in actually one for their region, happy to supply that for you and walk through it more if you want. So a whole house ventilating dehumidifier is ducted with the HVAC system. You can bring in outdoor air to get supply ventilation. Ours has a MERV 13 filter, so if you're in California, you're meeting your ventilation standard or code, and we dehumidify the entire home separate from the AC system. We're going to utilize the ductwork, but hopefully the most energy efficient way that you can set this up, I mean, there's other ways to do it, but the most energy efficient way is a dedicated return to the dehu, and then we tap into the supply, and we're only running the dehumidifier when the AC has come on, shut off, and hasn't met that relative humidity. And we'll go into some install options as well. I'm not going to go into that one. So it is supply ventilation. In a hot or in a humid climate, the building science experts agree that we should try to have a slight positive pressure on the house to try to stop that infiltration, because when it's hot and humid, everything's trying to get in our house through every crack and crevice, that we do a slight positive. Now, you can use an ERV and adjust those a little bit to put in more of a positive, with the understanding an ERV will always contribute to the moisture load. It'll lessen it, but it'll always contribute to it, and I've got some data to show that. The air can be filtered, again, slight positive pressure. We mix with the air in the supply, so if it's 30 degrees outside and we're just bringing in fresh air through the dehumidifier, we're not dumping 30-degree air into the house. We're mixing that in the box and through the ductwork before it comes out. And it's fairly doable as long as you got the room for a dehumidifier in a retrofit situation. Most of our dehumidifiers always go in for retro because we're always there to fix a problem. Builders have gotten into some problems, and they're realizing more and more that it's easier to put a dehumidifier in at the time of construction and not have to deal with warranty issues, remediation, that sort of thing. It's much cheaper to do it on the front end than on the back end, but almost all of our stuff traditionally has been retrofit applications. So this is when we are talking about using an ERV. Anybody using ERVs now? Okay. So typically in a humid climate, a lot of times ERVs are used. Colder climates, HRVs are used. But the ERV will exchange some of that moisture in the core. So if it's humid outside and drier inside, we'll bring in less. So if the air conditioning is running and we're removing water and it's drier inside, but it's high dew points outside, we'll exchange that moisture in the core and we'll lessen the load, but we're still always going to contribute to that load. So this is a case study we did in Orlando. Thinking it was about 5 or 6 years ago with the NHB, the International Builders Show, had their big show here, and this was their show home. The homeowners wanted to put in our dehumidifiers, but the equipment manufacturer, who spends a lot of money with the NHB, said, no, we're putting in an ERV. So we worked with the homeowner, and as soon as they got the keys back to the house after the show home, we monitored the ERV. And what you can see here is the blue line is the relative humidity inside the family room, and the green line is the dew point. So basically, the relative humidity, which was above 60%, was following the dew point outside. So we took out the ERV, we brought in their outdoor air with the ventilating dehumidifier, and we set it at 55%. And we don't care what the dew point is outside. we're just going to control the relative humidity inside the home. So this was a spray foam home. You can get tight homes without using spray foam, but again, the tighter our houses get, the more important it is that we're controlling that relative humidity outside of counting on our air conditioner runtime to do that. And we have this case study down on our table down there if anybody wants a copy, and it's also on our website as well. This was a study that the DOE did, Armin Rudd. If you've ever heard of him, he's kind of a moisture icon in the building science industry. But basically, he just said that if it's humid outside and it's humid in the house, you're not going to get any exchange with that ERV for the latent. I'm going to summarize this without going through it, but I'm just put it all out here. So ventilating dehumidifier. We've actually had some conversations already today. People automatically think that we're going to dehumidify the fresh air we're bringing in. Because that's what we do in commercial applications a lot of the time with the DOAS, is we try to remove as much of that moisture as possible before we introduce it to the building. The reality is, in residential applications, that would be very energy intensive to do for a small amount of fresh air. So we can bring in outdoor air, fresh air through the dehumidifier. If the compressor's running because we're removing moisture from the house, because the relative humidity in the house has gotten above 50–55%, we'll remove a little bit of that moisture that we're bringing in from that outdoor air, about 20%. If the dehumidifier's not running and it's time to bring in outdoor air based on our ventilation strategy, we'll bring in the air, and then if that makes the relative humidity in the house go above the set point for the dehumidifier, then we'll bring on the compressor for the dehumidifier. There are some companies out there that do sell dedicated dehumidifiers for fresh air, so you're bringing in 150, 160 CFM of outdoor air. Just like an air conditioner, we got to load those coils before any of that moisture is going down the drain. Plus, we're generating heat to remove that moisture and putting that heat into the return of the AC system. And when we do that, we reduce the effectiveness of the latent removal from our air conditioner because we're heating up the coils of our AC system. So, and that's in one of our install strategies that we'll talk about not to do as well. But does that make sense? So it's hard because everybody's like, oh, ventilating dehumidifier, you're going to remove, all the moisture from our humid outside, and that's not the way that we look at it. We really care about the relative humidity inside the house. Sometimes, it might be a little bit too dry and it's a little bit more humid outside. We might want a little bit of that moisture outside. All right, well, so here's our full line. You have a size house, we have an application for it. This is our recommended install for a dehumidifier. We like to have a dedicated return, if possible, to the dehumidifier. Then we tie in to the supply of the HVAC system, ductwork. And then all of our dehumidifiers have a dedicated fresh air duct, except for our smallest 70 pint unit, because it's so small you have to tie into the return duct to bring in fresh air. You don't have to use it if you're using an ERV to bring in your fresh air and you just want a dedicated dehumidifier. For the rest of the house, you don't have to use the fresh air on this system. And the reason we recommend this install is it's the most energy efficient way to run a dehumidifier because we're not utilizing the fan on the air handler or the HVAC system at all when we install it this way. If we were to do a dedicated pull from the return, which you can, we have other installs on our website. If you were to pull from the return of the HVAC system and then go into the supply, we would either have to have a check damper in here, or we would have to run the fan on the HVAC system so we're not just circulating air right here. So you either have to run the fan or a chuck damper, and I hardly anybody uses a chuck damper in an application. They just run the fan, which is okay to do as well. But again, you're running the largest fan in the house when this already has a fan in it.
Let me ask,
Yeah.
so if the air handler fan continues to operate, the backdraft damper is going to close, and you're not going to get any air going across the ultra air. So in other words, as long the way that's set up right there, you're putting air in on the supply side, so it's going to be going against the positive pressure from the discharge side of the HVAC system, right?
So right here.
Yeah. So that backdraft damper closes.
Yep.
When the air
When the air handler's on.
So if as long as the air handler's operating, you don't get any air across the dehumidifier.
As long as the air handler's operating. So if this is running, we're not getting any air this way, going backwards.
Well, you're not getting any air going backwards, but you're also not going to get any air going forward.
See if you're pulling the return from the HVAC.
Oh,
So in other words, theoretically, if the air handler fan ran all the time,
Oh, yeah.
you would never get any air across the dehumidifier.
not if you locked it out.
Well,
No.
I mean,
Yeah.
that's the way- that's
Yeah.
the way you've got it.
Yeah. And hopefully we're not running continuous fan because we're evaporating, in theory, evaporating all that water off the air handler if we run continuous fan.
Well, I mean, the problem is you're talking about oversizing and undersizing, trying to get it undersized so you can run the unit long.
Yeah.
Well, the more you run the unit, the more the backdraft damper is going to be closed,
Yep.
and the less time you're going to have air.
And if you're going to have longer run times and you're still concerned about hitting that relative humidity, you can run the dehumidifier and the air conditioner at the same time too. I mean, that's an option. On our controller, you can lock it out from that happening. But I will say in the industry, most of the time, that doesn't happen. If the relative humidity goes above the set point and the air conditioner is running, they'll just run the dehumidifier at the same time too.
In that example, that backdraft damper wouldn't close unless the static pressure in the HVAC supply duct was higher than the ultra air dehumidifier is putting out. So and I don't know all those specs, and obviously it's going to vary.
So if you're running at a really low CFM
Yeah, it takes a little bit of setup and testing
to get it, that makes
figure out how
sense.
to make that work.
Yep. So there's,
They could run at the same time if the
As
ultra
long as
air
as
had
long
a
as
higher.
your supply pressure from, or supply, static pressure from the ultra air is greater than.
Higher, yes.
Usually continuous fan would be a much lower fan pressure anyway.
yeah, that's true. Depending. If you're at a static pressure of 0.5 or higher, we recommend not installing the dehumidifier. So we start having concerns at that static. But our engineering department and our applicant, I mean, if you have a situation that you have a question about, again, we invented these. We've been in the industry longer than anybody. Even if you're using somebody else, which happens a lot, we get calls to help with installs all the time. So just let us know. We'll give you cards. Oh, sure.
You know what the temperature rise is on a typical unit for a residential system?
About 20 degrees difference. So from the incoming to the outgoing. So that's why we got to make sure on this supply we get probably 5 to 10 feet of mixing in there before our first drop. And you got, just because we don't want to, all over the easy chair in the living room, we don't want that going in. So we need some room to mix that air. Because our 70 pint unit's 150 CFM. I mean, it's not a lot of CFM of heated air, but there is heated air.
Yeah, I was curious to why you wouldn't need the AC system. Now I understand why.
Oh, you can, yeah, absolutely. If somebody's sensitive to that, but I will say that usually if we get a complaint about it and we fix that, usually it's not a problem. All right, so let's see if I can get this. Oh, there we go. To run here. So just an illustration, dedicated return to the dehumidifier. We got a fan inside. We can bring in that outdoor air. This is one of our larger units that features a heat exchanger inside, which allows us to pre-cool the incoming air to get to dew point faster. So if you need a larger dehumidifier and you're worried about the energy efficiency or the energy usage, these units are probably a good solution because we are the most energy efficient dehumidifiers on the market. And then we just use the supply of the ductwork. All right, so no existing ductwork if you're using ductless mini splits. One of the challenges of using ductless mini splits is trying to figure out your ventilation strategy, your air filtration, as well as getting air mixing and distribution throughout the home. So we work with a lot of ductless mini splits where, yes, now we're going to have some ductwork in the house, but it's going to be minimized. Dedicated return, and then off that supply, we typically recommend 3. That's again because of the heat. We don't want to dump it all into one area. We want to spread out where we're putting that, and typically those supplies will go into rooms that have the ductless mini split heads. So we make sure that we are, cooling that air a little bit as well. Good. All right. Return to return. Anybody using, first of all, is anybody using dehumidifiers? Anybody doing return to return? Okay, so Florida Solar Energy a year and a half ago came out with a new study on the best way to install a dehumidifier. And actually as a result of that, they do not recommend return to return installs any longer. We have it as one of our installs because in all honesty for our service department, it is the easiest way to install a dehumidifier in retrofit applications. There's a lot of challenges where you can't get to that supply. So return to return has been one. But in our experience, I've taken the calls, I put in your dehumidifier 2 weeks ago and the relative humidity has actually gone up in the house. And what it comes down to is they typically did return to return install. And the challenge is the same as we talked about using a dehumidifier as dedicated ventilation. We're heating up the air that's going into the AC system. So we're heating the coils of that AC system, so it's not removing as much water as it used to, and it's also very energy intensive to do it that way. And when the AC system shuts off and it's loaded and the dehumidifier comes on, we end up re-evaporating that air back into the home. So it can be done successfully. There's a lot of cautions in doing it, but if possible, try not to do a return to return install if it's an option. We have a free app on your phone that you can download. Basically, what it allows us to do is to calculate how much moisture removal we're going to need based on ventilation alone. So if you're in a state or you're working with a builder or you're now required to do some sort of mechanical ventilation, this will help you calculate how much moisture removal alone you're going to need just based on the ventilation. So the inlet is what the temperature and conditions are outside. The outlet is what we want inside the house. And the flow is the CFM, or what our ventilation rate is. And that's going to give you how many pints a day of water removal you need. If you want to switch it from pints a day to pounds an hour, you just click on that little I and you can switch that. You can also switch Dewpoint to grains. So if anybody works in grains, you can switch it to grains as well. So just as an illustration, we've got a ridiculously high 83-degree dew point. 85 degrees outside. I want 75, 50 inside. I'm bringing in 100 CFM of outdoor air. I'm going to need about 180 pints of water removal. At peak load condition, depending on the size of your HVAC system, it'll probably keep up with this. The other thing you need to add into this then, would be how many people are in the house. So family of 4, 2 pounds of pints an hour. If they're home all day, you would have to add about 48 pints or pounds to that. But again, we're running at peak load at this condition. The challenge we get into is the no load and partial load days, 70 and raining. It's 70 and 100% RH outside. I want 70 and 50 inside. I'm bringing in 100 CFM. I've got 91 pints plus another 48 for the people. You know, this could go, depending on where you are, this could be a week in fall in a lot of locations where you've got some pretty uncomfortable homeowners and potential for microbial growth at this point. So here's a situation. How are we doing on time? Okay. Because still dehumidifiers aren't mainstream yet, right? So usually we're called in to fix a problem, or we've got homeowners that have something that's a little more unusual. This is a very recent call I got. 1,500 square foot townhouse in Maryland, and the wife has an immune deficiency, hypersensitive, and because they're in a townhouse, the engineer tried to design their ventilation system to put as much positive pressure in their unit to stop the infiltration from the side. They did do a lot of air sealing, which is always my first question. And then, but in order to accommodate the extra load from the ventilation, they upsized the HVAC equipment as well. And then they put in our XT105, which is the most energy efficient dehumidifier on the market, to help bring in ventilation. So they couldn't use us strictly for ventilation. They were also using a supply ventilation fan to try to get to this 300 CFM inside. And they installed it return to return, the dehumidifier. So I ran the calculations, and based, if worst case scenario dew points in Maryland, 74 or 70 degree dew point, some days they're gonna need 300 pints of water removal a day based on that. And because they upsized the AC system to deal with the heat load, they also weren't getting as long as run times on that AC system to remove as much water as possible. 105 pint dehumidifier, and this is one thing to and we're gonna go into this a little bit too, is all dehumidifiers until just recently are rated at 80 degrees and 60% relative humidity, which is basically an indoor pool situation. We don't control that. That is what Energy Star rates our dehumidifiers at. It's not realistic. They recently just changed it to whole house dehumidifiers at 75 and 60, and then basement crawl space dehumidifiers at 65, 60. All of our numbers are going to look a lot worse, but it's reality and it's a level playing field. We try to be as honest as possible, especially because we work with a lot of engineers, but we didn't want to publish those numbers because our competitors didn't publish those numbers, and we don't look as good on paper, but now it's a level playing field. But if you called us and you wanted the actual specs, which we'll be supplying these on our spec sheets now, what you want to look at is, okay, we have 70 degrees and 60% relative humidity on a 105 pint unit, we're getting 76 pints in reality. That, because it was rated at 80-60 and that was 105 pints, but the reality for the more realistic applications are these numbers. So they're using they need 300 pints of water removal, they're using a 105 pint dehumidifier and they're getting 76 pints of water removal, plus they have it return to return install, which, you know, we're rehumidifying some of that air off their AC system. This is our 205 pint. We make the largest residential dehumidifier, ducted dehumidifier. Even this one, they're only getting 156 pints of water removal. So our first strategy right now is, because they are adamant, and I still trying to get where they get the 300 CFM. Where is that coming from? Who decided that that was going to make her healthy? I don't know. But we're going to get the current unit they have, the 105, set up, return to supply, and see if if that will help us a little bit. And I think we're just gonna, I told them they're gonna have to go to this unit if they're gonna continue to do that. And I wouldn't even be confident that this unit would do it in Maryland with a 70-degree dew point most of the summer. So we have a lot of challenging situations out there. A dehumidifier will help, but it might not, I mean, they might have to go to a commercial application or get out of a townhouse so they're not so worried about what their neighbors are doing. So, but again, if you guys ever have those challenging applications, reach out to us and we'll help all we can, and obviously be very honest and realistic about what a dehumidifier can do, because we want it to be successful.
Out of curiosity, do you know what the positive pressure is like in there with 300 CFM of outside air? That's gotta be really
So they must have did a blower door, right, to see how much their infiltration they were still getting, because they did go in and do air sealing. So they must have done a blower door, said, okay, we're still getting this amount of infiltration. So if we do 300, maybe that will stop it?
Well, with everything closed with 300 CFM, that's going to result in some amount of positive pressure.
Yeah, I don't know.
It's got to be high.
It's got to be high. Yeah, I don't know. SD12, just to go over a couple unique units. We have a split dehumidifier, so if you are sensitive to the heat from a dehumidifier, we put the compressor outside, so you'll get first stage cooling as a byproduct of dehumidification. So very unique unit. We've got specs down there if anybody wants any more. It's a biggie. It's 180 pints of dehumidification, or 84 pints of dehumidification. Commercial kitchens, great application. You're getting a lot of dehumidification with first stage cooling as part of it. A lot of additions, we see this going on as well. A lot of homes that want dedicated dehumidification and might just need a little bit more cooling. In-wall dehumidifier, we have this down at our table. Newer product for us, last couple of years. Anybody working in multifamily applications where you don't have room for a ducted dehumidifier, you can put this in the wall. Basements, and also like storage rooms where you need to try to keep some a relative humidity. That's what it looks like. This is a passive house in Dallas, Texas, where they used all ductless mini splits. And then they just ducted that into the plumbing of the bathroom because their building code allowed them to do that, and plugged it in. Cautions here, we just want to make sure that when we do this, we're not discharging that warm air right on. This was about a 200 unit project in the DC area. So we just had to move that thermostat. This is a hallway on the other side of the wall there. Drain traps, very important with dehumidifiers. This is an easy trap. Supply House has them for $9.99. Great, because you can see when it starts to goop up. You can flip up the cap, you can clean it. Love those drain traps. How to size a dehumidifier. So AC removes approximately 2 to 3 pints of water per ton when running. How is the AC sized? Peak load conditions. How often does it run at those conditions? About 1% of the time. We also need to make sure that we're always thinking about our fresh air, whether you're using mechanical or whether it's infiltration. Your air's coming in one way or the other. And the dedicated dehu will always. So best practices, again, what we're looking at here is 7170 is our latent load, right? So manual J, right here. Page, if you have it, page 49 talks about sizing a dehumidifier. If you are working with builders, we are working with a lot of builders in Houston right now that are facing a lot of issues. And if you are working with builders and they are on the fence about using dehumidifiers, don't want to use dehumidifiers, having a reference to something like Manual S that says, yes, you should be using a dehumidifier and here's how to size it correctly, that might help them and cover you a little bit as well. But how to calculate dehumidification based on Manual J, this is the calculation to get to how many pints per day based on your latent load. So if you take the latent cooling which was at 7170, divide it by 1054. That's how many BTUs it takes to remove a pint of water. And this will equal, where did we get that 6? Oh, then you have to times it by 24. And that gives us how many pints we're going to need a day. I'm happy to share this presentation with anybody as well. I don't know if Brian's sending them out afterwards, but I can email it to anybody also. So Manual S, this is what Manual S says in this book right here. We want the pints per day to equal 24 hours times the latent BTU divided by the latent BTU. So we have 163 pints per day. That's the calculation there. And then what Manual S says is, well, that's at 80/60. So our latent, what we reported is 163 pints, right? So they're saying, well, that's not realistic. You need to do it for 55 in order to get the real number of dehumidification. So you times that by 0.76. And so our 205 pint unit at 80/60 is really 156 pints at 70/55. And those equations are all in Manual S, and again, I can share this with anybody if they're interested here. So if you're doing your calculations for your latent loads as part of your Manual J, with the understanding that that's at peak load days, how are we going to control the moisture the rest of the time? Okay, we're going to use some variable speed. That's good. But we're still going to have days where we don't have the sensible load at all, and we're going to need dehumidification. Parts of the country, Northern Virginia, Mid-Atlantic, 2 summers ago, we had a lot of latent load, and we just couldn't run the air conditioning enough to deal with it. This covers you. When you reference to any builder that you're using Manual S to size them a dehumidifier for the times of the year that their AC isn't going to remove that much water, this gives you credibility and also protects you and potentially the builder. So you can be off about within a 15% range of what that number was, is basically what this is saying for the size of the dehumidifier. I'm not going to go into this here because I think everybody's tired of me talking and I'm tired of listening to myself. But if anybody follows Joe Steenbrook, building science, very smart guy. I just attended one of his presentations, and it was all about energy efficiency and making our houses tighter. And now you're telling us we have to use a dehumidifier. And he's like, 10 steps forward, 1 step back, and you cannot energy conserve your way to dry. Just like ventilation. You can't energy conserve your way to indoor air quality. It's going to cost you something for a dehumidifier, but if we set it up correctly, hopefully we're not using as much energy as an AC system would to use a very energy efficient dehumidifier to get to a set relative humidity set point. So RedCalc, if anybody's using this, you can go on there and there's an electrical usage for ventilation. This is our 90 pint dehumidifier, 670 watts. I said I was going to use it 270 days of the year. I'm going to run it 20 minutes out of every hour. Sometimes it'll be more, sometimes it'll be less. My cost per kilowatt is 11 cents. So we're at $159 for the year to run the compressor on the dehumidifier. I did not calculate in here the fan usage, which we work with Jeremy's team a lot on energy modeling, and so we will be putting the fan use watts on all of our spec sheets going forward, because as that becomes more and more common running our HERS ratings and stuff like that, we need to know what the fan wattage is, and every unit's different. Our 70 pint unit is 85 watts for the fan. So we have all those numbers. All right, so in conclusion, HVAC D, the AC is not using the D, or not doing the D anymore as much as it should be. We're doing everything right. I talk to builders a lot. Everybody wants to point fingers if you need a dehumidifier. Somebody did something wrong if I need a dehumidifier. But the reality is if you're building tight, you're bringing in mechanical ventilation, and you size the equipment according to best practices, which is Manual J, and you need a dehumidifier, you actually did everything right. I mean, it's just our building practices are changing. Not everybody used to have AC. Now everybody has AC. We're building tighter. Probably in a large part of the country, we're going to have to need dehumidifiers as standard practice. And all right, crawl spaces, basements. We also manufacture Santa Fe standalone dehumidifiers. This picture does not show it, but this illustration shows it. If you can, in a crawl space application, run some flex duct off that. We have dual exhaust on our dehumidifiers. For standalone, try to get that air away from the front of the dehumidifier because the RH sensor is on board right here. And if we can get that dry air away, then we don't create a microclimate right here where it's just sensing the dry air and not running enough and not getting that drier air to the farther spaces of the crawl space. All right. Up next, commercial, light commercial. If anybody's doing?
Does anybody have any questions for Nikki, though, before we go down this path? There's a lot of information.
Yeah, you mentioned Maryland being on 2015 or
18.
2000 which one?
18.
18? Oh, okay.
Yep.
'Cause we're on 15 now here.
Oh, okay. In
But
Florida?
there may be enough sensible load that it's still not quite. Maybe we're still kind of on that borderline where I know some new homes.
Here in Florida, you're saying?
Yeah, 'cause I
You don't have to do ventilation though, because you guys wrote your own ventilation.
We don't right now.
It's
unless
coming.
We're less than 3.
Less than 3.
50, which
Isn't that great? Nobody wants to get tight because I'm going to be penalized if I get too tight. I don't know if you know Gary Nelson. He invented the blower door. I was on a plane with him yesterday, and he's like, "What is this? What is this that I hear about Florida? That it's actually a bad thing if you get too tight?" I'm like, "That's kind of how it's."
7 is where but it'll change with the next build cycle.
So we just had one of the largest production builders in the country in our office in Madison, Wisconsin this week because they know that Florida is going to be going to enforcing mechanical ventilation at some point, and they want to be on the forefront.
Will it be the next code cycle? Or
I have no idea. I don't know when it's going to happen, but they want to be prepared, and they know the only way they're going to be able to do it is dedicated dehumidification. And if you Google anything about Houston and litigation in builders right now, it's a huge, huge issue of what's going on. They've oversized. They have to bring in fresh air, and they have a lot of homeowners that.
In our market, everything's oversized. I just did a blower door test for an owner builder recently, and they had a spray foam. They had a 1,400 square foot house, spray foam insulation. I think it was facing north. Very, very little glazing, and it was all, of course, really good low E stuff. And they had a 3-ton.
Yep, they have no heat
with
gain.
fresh air intake that they knew they were going to need because they thought they were going to come in under 3. They ended up coming in like 3.1.
Yeah.
My brother does air conditioning sales for a big company right up here in Melbourne, and they deal with a lot of production builders. And for the past 2 years, they've been doing dehumidification standard on all
Yep.
of their.
It's getting
stuff
there.
That they do just because they ran into a lot of problems already because spray thermatics and all kinds of stuff that was out of their control. So they're like, we're just going to go ahead and do it standard because they get blamed no matter what.
Oh, they do.
Spray
Yeah.
thermatic, HVAC guy did it. It doesn't matter. You're the if something's wrong. With
Everybody's
it.
pointing fingers.
So
Yeah.
It's not drying out. It's their equipment, whatever. So it's not always their fault, but that's a good Band-Aid solution to make sure that they don't get blamed for something that's not their fault.
And we're very involved. I sit on the building envelope committee for SPFA for the spray foam. And not that I believe in spray foam either way. You can get a very tight house not spray foaming. I mean, you can caulk the crap out of a house and you can get very tight. But when the recession hit and a lot of insulation contractors weren't doing new construction anymore and they all went into retro, we were getting calls from homeowners that are like, I just added this insulation to my house and now I've got smells I've never had, I've got moisture issues. I mean, that AC system was completely oversized in the first place.
I was doing retro during that era, during the Obama era. I had a company called Cincinnati Energy Solutions. That's all we did was straight home performance. And many times, I can tell you that somebody called us back and said, I had to go out and buy this dehumidifier and I'm emptying it every 15 minutes because I don't know what's going on
Yep.
in my house. And at that time, there wasn't a lot of forward thinking about dehumidification out there. So it was like, we'd have to resize the whole entire system, install something totally different, and just hope we solve the problem that we created in the first place, just by tightening the house.
And what's amazing, and I think builders are, moisture is the #1 detriment to any building. But they don't want to spend $2,000 on the dehu and the install of the dehu. But in the long run, we deal with it in multifamily all the time. You got to move the tenant out. You got to do remediation. You've lost rent on that, and guess what? It's spread like wildfire now. And if you would have just put in a $800 in-wall dehumidifier to begin with, because as soon as you go to retro it, then the contractors, they're charging a lot more.
A lot of the bad thinking is a direct result of the emphasis on energy conservation measures throughout the years, because they put so much emphasis on energy that people were like, we're already spending all this money to satisfy the energy stuff you guys want us to do. Why should we have to put this other piece of equipment in that, in their mind, is caused by the energy stuff in the first place? If we didn't do all that, we wouldn't have this problem to begin with.
Well, and now you're getting.
Contravenes conventional wisdom, right? So I hear that all the time in the green building world around multifamily, is that, wait a minute, so you're telling me that I have to put a dehumidifier in to save money to meet a green building prescription, which is energy conscious. And so that's the thinking that has to change around dehumidification. When we can remove moisture from the atmosphere at a much higher coefficient of performance than air conditioning can, it makes a lot of sense, and it's not just that Band-Aid that you're talking about, because we're actually more efficient in a lot of situations. And then you roll that over into commercial. I pin this to my lip. Is that how that works? Pin them shut, preferably, right?
And then you get the incentive to put in higher tier systems for rebates and stuff like that as well. We just don't have a big enough lobbying for dehumidification.
That's why I like the model code the best, because you can model that 13th SEER out of there, and you can keep on that 13th SEER and do other stuff that makes more sense. When you have this prescriptive requirements of 13th and 14th SEER, somebody's saying 16th SEER is the thing that should always be installed. A lot of times you are creating problems that you better solve and conserve the same amount of energy a different way.
Yeah.
So I'm a big fan of a single stage option, and we call it the comfort option, and we integrate a ducted dehumidifier with a single stage HVAC system, right somewhere between that basic system and the variable speed multi-stage system. You call it a comfort option, and you price it accordingly, and you'll sell it like crazy, especially down here in this market. And then the sizing issue on the air conditioning side kind of goes away, right? So if you've got that extra component, that piece that's just measuring the moisture content and running on demand to move the moisture, then if you're a little bit oversized or you're a lot oversized, it really doesn't matter, right? Still need to be right sized, but I'm not advocating putting in grossly oversized air conditioning, but it does create a fudge factor that's usually beneficial for comfort and for energy. And it's not just your market; it's lots of markets where we're oversized, especially in multifamily townhouses and stuff. So my background is low-income housing tax credit construction and development, multifamily, and so the genesis for the wall unit comes directly from that. So in North Carolina back in 2009, they went to Energy Star 2.0, and we had to start building all these air-sealed apartments. And as a result of that, we noticed that within about the first 10 months of occupancy, especially ground floor, slab on grade, north or south facing apartments, we were growing mold like crazy, and we had no idea what was causing it. So that took us down the building science rabbit hole, and here I am advocating dehumidifiers now, 6 or 7 years later. But I believe in it because it solves a problem. Not only is it the most practical approach to solving that moisture issue, with this company, with Ultra Air Therma-Stor, there's a focus on doing everything we can to the most efficient level we can. So we're building the most efficient dehumidifiers in the world, which makes a big difference. And so I've got a little bit of time. We're not going to be able to get through all this commercial stuff. So I will say this: if you don't know how to evaluate the efficiency of a dehumidifier, it's based on the coefficient of performance, which is measured in terms of pints or liters per kilowatt hour. So when you're evaluating our stuff against anybody else's stuff, look at the comparable size units and pinpoint that that coefficient of performance or energy factor, it's called in some of the literature, and pay really close attention to the pints per kilowatt hour, meaning how much moisture we can extract from the atmosphere for a kilowatt hour of electricity versus the competition. Because there's a lot of cases, particularly in that 70 to 120 pint range, 130 pint range, where we knock the socks off the competition. Speaking of socks, we have lots of socks up here. Okay, come on, guys. Little chuckle. Nothing. All right. That's good. That's better. So, to kind of reiterate something that you said, sir, we're laser focused on this efficiency piece. When we set out to design a mechanical system, we could all agree that this is the criteria we're trying to hit. We want to ensure that mechanical system provides for the health of the occupant, the comfort of the occupant, the durability of the structure of the building, and also the efficiency. But with green building, in a lot of cases, we're laser focused on the efficiency, and it's often at the expense of all or one or all of these things. And anytime we're in an elevated humidity or moisture situation over a long period of time, it does impact all of those things: health, comfort, and durability. We do a lot, as Nikki mentioned, a lot of stuff where buildings have failed, where they're having to go in, move tenants out of apartments, and then clean those apartments up, and obviously that impacts all of those things. Comfort being the least concerning of which. I don't know how to use this contraption. What button should I push?
The one on that one where
This
your
one?
thumb is? Maybe. There you go.
So ASHRAE has a term called complex causation. It's just a fancy way of saying anytime we experience moisture-related problems significant enough to cause building failures, it's not one single, you can't put your finger on one single thing. And so this comes up in court a lot, right, in litigation, where you have a big failure and the contractor points his finger at the architect, and the architect points his finger back at the contractor, and the developer's pointing his finger at everybody. And so you have these lawsuits where the only people that really benefit are our attorney buddies who love that sort of stuff. But really, we're all responsible, and that's what we're trying to tell you here is that, the owner developer, the architect, engineer, contractor, the resident has some buy-in, whether it's owner occupied or rental, and then anybody that's managing or operating that property. It's in all of our best interest collectively to get together, to make decisions at the design standpoint, at the construction standpoint, at the installation and operation, and even at the space that we're inhabiting, to do things that make sense. What doesn't make sense, again, and what we run into a lot, is where you have a rental property that a developer has spent a bunch of money to build, and we've done a really good job on the engineering side, designing the mechanical system. Contractor's done a bang-up job putting the system in, and then the resident moves in there, and in the dead of summer turns the air conditioning switch to off, and then goes on vacation for a week or two, right? And then comes back and says, I've got furry walls and I've got mold growing on all of my stuff or half of my stuff, but it happens. It happens probably more often than you'd realize. So we all got to get buy-in. It starts at design and it goes through occupancy, right? And we avoid these moisture-related building failures. I'm gonna skip through all of this stuff because Nikki talked a lot about it. This is a pretty neat tool online, though, if you're not familiar with it. At that URL, I'm from Texas. I'm a product of the Texas public education system, and when I try to talk fast, it's problematic. It starts sounding like Chinese, and especially if I'm up in the Northeast, nobody can understand what I'm saying. So this URL, dpcalc.org, it's for the storage industry. They put this thing together, but it's a Dewpoint calculator, and it also has like some material preservation factors, and you can play around with these numbers being temperature and relative humidity, calculate a dew point, and it'll give you some aging risk factors. And but what's interesting is it has this mold calculator component where this was the conditions of a senior housing project in Virginia Beach, Virginia, that Nikki and I had to go out and visit. It was a 10-month-old apartment, coastal Virginia, built to a green building platinum standard, oversized mechanical short sizing, and a resident that had the thermostat set to 78 degrees. Yeah, there it is right there. That would have been a clue. 78 degrees. And when we walked in the apartment, it was 69% relative humidity. So what that calculator tells us is that under these conditions, if they were to remain constant for 221 days, you would have microbial growth And so the more moisture, the higher temperature, obviously it accelerates that. But if we use 60% as a baseline for relative humidity, it doesn't matter what the temperature is. You could run this up to 88 or 98 for that factor, for that matter, and you wouldn't have a risk to grow mold inside that apartment. So Dewpoint is more meaningful. We'll get there as manufacturers at some point, I hope. But right now, what we've got is relative humidity, and that's the threshold. Keep it below 60%, right? Anybody ever go out on one of these? Is that Brian in that condensing unit changing out? Is that, I think that's Brian, right? That might be Brian here. So air conditioners have gotten bigger, right? And I'm dating myself here. Anybody in the business back in the early 90s remember what a 2-ton evaporator coil looked like? It looked like a lunch pail. You know, it literally looked like a little lunch box, right? What does a 2-ton evaporator coil look like now? You know, it's like this, right? So it's all getting bigger in and outdoor. And the reason for that, real quickly before we move on to this, is as a manufacturer, when you're focused on improving SEER rating of equipment, what's the most common way to do that is to use oversized evaporator coils, right? So we're using larger coils. And then what happens is, or why do we do that? It's because we lower the compression ratio. But in so doing, we increase suction saturation temperature on that same evaporator coil that's now oversized, it's now holding more moisture, and then we do things like time delays on relays and stuff in the control logic to bump the SEER rating up, and all of that stuff works against latent capacity of the AC system, which that's why a 14 SEER single stage comfort option with a dedicated ducted dehumidifier like the UA98 out there, it makes a lot of sense. So in the commercial world, this was a really good article. Anybody know Glenn Horhan? So he writes a lot for ACA. If you read the Follow the ACA publications, you'll see his stuff from time to time. He's a really smart guy. But he's talking about here in this article the impact of airflow on cooling capacity and latent capacity of a 10-ton rooftop unit. So at 4,000 CFM, we're getting 91,500 sensible, 34,300 latent. If we decrease airflow, we increase latent capacity, just like Nikki was talking about. This is just on a much bigger scale, right? So by decreasing airflow from 4,000 to 3,000 CFM, we decrease sensible to 79,600, but we increase latent to 41,100. And then if we go in the opposite direction, if we increase airflow to 5,000, we increase sensible to 102,000 BTUs. But look what happens with latent capacity, how far that's diminished by increasing that airflow. So it's up or down essentially 20, it's up 20% to lower that airflow. It's down almost 25% to increase that airflow on that 10-ton rooftop. So, this is a 10-ton. So usually a 10-ton rooftop is sitting on what? A big space, right? So what do we need for bigger spaces? We need more airflow, right? So we have a tendency from a latent standpoint, in a lot of cases, to increase the airflow to reach the areas that we need to reach at the expense of latent capacity of that system. So then if we don't order this system with hot gas reheat and we don't have additional incremental dehumidification capacity, we're in trouble, right? So lowering the airflow might not be the answer. We have products that go up to 876 pints in refrigeration-based dehumidifiers that can help you solve these sorts of issues if you run into them in the commercial world. There's a lot of moisture in the air when we're setting up these systems for ventilation. This is, what's closest to us here. So what this chart represents, and Lou Harriman, if you're familiar with Lou, if you followed Joe Stiebrick in the building science community, you've heard Lou Harriman talk. Lou and his crew did this work and published this for ASHRAE back in 1997. So again, talking about going back a little ways. And this was for calculating ventilation load indexes for commercial systems. And what the blue line represents is latent ton hours per standard cubic feet per minute per year versus the sensible, which is represented in red or pink here. And this chart does a really good job of demonstrating how much moisture is in the outside air that we're bringing into a structure. It doesn't matter whether it's residential or commercial or whatever it is. If you live in one of these geographies, it challenges kind of our concept of what high humid environments are or what mixed humid environments are, because we all know that New Orleans and Miami and San Antonio and Charleston are all high humid. Traditionally, we think of those as high humid climates. But what might be surprising is that in Indianapolis, Indiana, or Lexington, Kentucky, or places like St. Louis and Oklahoma City, Richmond, Raleigh, Atlanta, Nashville, all have 4 to 5 times as much moisture in the incoming air, outside air, as what there is heat that needs to be accounted for by the mechanical system. So moisture is a big deal, and like Nikki said, even in the residential world, doesn't matter whether we're positive, doesn't matter, matters less if we're balanced. Doesn't matter what the ventilation strategy is. If we're running exhaust only and we're allowing infiltration, or infiltration makes up our makeup air, you still got all this in it to contend with. And that needs to be added to and considered when we're designing our systems or calculating our loads. Just give me when we get to time. So same chart, different view. What am I doing there? So again, Nikki mentioned we do a lot of work in failed buildings. This is actually in Tampa, so not too far from here. This was an apartment project where they did a substantial renovation. They did a rehab, put new roofs on, put new windows in, buttoned up the building envelope, did not change the mechanical system. So they didn't anticipate that all these structural changes they were making to the building was going to impact how the mechanical system worked. And as a result of that, they were running high humidity and they were having to clean up apartments and do mold remediation. So they hired a consultant. The consultant came out and he took a bunch of pictures and he took a bunch of measurements. He left some data loggers and he said to them, all right, the way you solve this problem is you use dehumidistats. So you can get this communicating thermostat for a couple $100, and you put those in and you override the temperature, and that's going to force the AC to run longer, and that's going to solve your problem. So they did that. They went and they bought a bunch of communicating thermostats, and they put them in at a cost of, I don't know, $500-600 an apartment. And this is the result that they got in almost all the cases. So this is apartment 124. So the temperature was set to 70 degrees. Relative humidity was at 60, and they could not get the relative humidity to consistently remain below 60 degrees. And you'll see that the apartment had exceeded the set point and was overcooling to 68 degrees, which may create some comfort issues. It certainly creates an energy issue, right, an efficiency issue, because we're cooling past the place where we'd be comfortable. So right down the hallway, they put in one of those in-wall dehumidifiers that are out there, and they set the temperature to 74 degrees inside the apartment, and you can see it was maintaining, set point was 74, temperature was 75, but more importantly, the relative humidity was 50%. So if you're not familiar with the apparent temperature effect, we as humans are comfortable at higher temperatures with less moisture in there. It's the same reason that when you go out here in the summertime and it's 92 degrees and 70 what or 80% relative humidity actually feels warmer than it is. The same thing happens inside these spaces. And so this, for most people, for most humans, is a much more comfortable environment, and you also don't have to worry about fuzzy walls. So again, going back to Nikki's presentation, relative humidity and not fully understanding kind of the relationship between grains or absolute moisture versus relative humidity. You can run kind of the sample on this to see, and these are pretty similar conditions in terms of grains or actual moisture inside the air. But on the energy side, where are we spending the most energy? Are we spending a lot of energy with that air conditioner in the spring through fall to cool to 68 degrees? Or I should phrase it like this: more energy here, yes, or more energy here at 74 degrees, right? A lot less energy is being used over here, and oh, by the way, that dehumidifier that was put in there that solved this problem pulls 2.8 amps when it's running, only when relative humidity or moisture is accelerated or elevated inside the apartment. So much more efficient way to condition the apartment. So reheat, you're all familiar with reheat. It's used quite a bit, sometimes effectively, sometimes not as effectively. I talked to a gentleman today. We were talking about ray wall valves. Everybody familiar with a ray wall valve and know what that is and why we use them? I was contacted recently by a commercial department at a distributor down in the South Alabama area who said, hey, look, we're ordering these heat pumps, these DX systems. We're having to send the heat pump off to have it outfitted with a reheat valve, with a ray wall valve, essentially. They get damaged half the time on the way to get upfitted, and they get damaged half the time on the way back, and we have to restart the process all over again. And oh, by the way, we pay freight both ways, and if we're having to eat damaged equipment, and it takes a long time to do it, right? Why don't we just use your dehumidifiers and that we sell, that we have on the shelf, in place of these reheat devices? Young guy, young engineer, very, very bright guy. And I said, wow, I never contemplated that. That's a really good point. So in order to do that, we have to go out and we have to talk to engineers and designers about why it makes a lot of sense to do exactly what he said, which is take one of the high efficiency dehumidifiers off of the shelf and integrate that into the system, as opposed to going to all the trouble and expense and effort of upfitting DX refrigeration heat pumps with reheat devices. All for the sake of forcing those AC run cycles to run longer, where you're using more electricity, right? So you could do it with this sort of dehumidifier. We see that a lot. I pulled up at an apartment complex somewhere, and that was what was sitting on the sidewalk, and it made me smile, because that's not the best way to do it, not just because it doesn't say ultra air, but because the efficiency of this sort of dehumidifier, again, when we're talking about pints per kilowatt hour in electrical consumption, is somewhere in the 1 to 3 pint per kilowatt hour basis, where we can do it at a much, much higher and more efficient rate. So you could do that, but it usually doesn't work. So standard refrigeration dehumidifiers are the lowest cost. They remove 1 to 3 pints per kilowatt hour. They cannot operate in low dew points. So when you get to a point where the temperature, for the storage industry, we get to a point where your ambient temperature and everything is dropping down below 55 degrees, these things are not pulling any moisture. I don't care what it says on the data sheet, it's not pulling any moisture. Low grain refrigerant dehumidifiers, which is what we manufacture, in the example that Nikki showed earlier, similar to our XT platform, are the most efficient. Will pull 4 to 8 pints per kilowatt hour and achieve lower dew points at cooler temperatures. So they work better in a wider range of temperatures, and they're a lot more efficient. And then desiccant, if you needed to operate at a dew point below 40, or the room temperature drops down below 55 degrees. So cold storage, these sorts of applications, you really need to switch over to a desiccant in order to get proper moisture removal in those environments. They are the most expensive in terms of upfront costs, and they're also not very efficient in terms of electricity. So this is where you want to be if you can be in that LGR category. Do a lot of climate controlled storage. This is not what you want to see if you're in the storage business. Storage unit renters stunned by mold on belongings. New self-storage facility just opened 6 months ago. So if you're in that sort of industry, that's never good for your business. The way you avoid being a part of that headline is higher and drier. So this reduces electricity consumption and operating costs, protects the contents, more importantly, from elevated RH and microbial growth. For storage facilities, there's no reason in the world to maintain a temperature below 80 degrees, right? We're not conditioning that facility for people. We're just preserving whatever's being stored inside there. So you'd be surprised how many of those facilities are designed to maintain, 74 degrees, 75 degrees. That's not the indoor design temperature for a storage facility. 80 degrees is the bottom of the threshold. 50 to 55% relative humidity is what's much more important. And guess what? That's a lot easier to achieve at 78, 80 degrees than it is at 74, 75 degrees, right? So here's just an example. This is the old school formula for if you're in that sort of business and you want to run calculations. If we were to use an example of a 10,500 square foot building with an 8-foot ceiling, which is a terrible example for storage, right? 84,000 cubic feet. Our design dew point inside is 72 degrees. And we get that for 72 at, let's see, I lost my place here. Yeah, so we're using grains. So this is a good example of what Nikki was saying. If you want to switch over and use grains as opposed to dew point, you can do that with a calculator. So design condition is 72 degree dew point. We've got 120 grains outside. Inside, we want to maintain that 80 degrees and 55% relative humidity, which is 84 grains. And that's what we've got set up over here is 88 out, 60%, Inside, we want to maintain 80 and 55. So the grain depression here is the difference between 120 and 84, which gives us 36, right? We're assuming a construction leakage of 0.2, which is pretty much what's being built now for that business. 0.1 would be super tight, Yeti sort of house, and then 0.3 would be old and leaky. But we take our cubic feet, we multiply that times our building envelope factor or ventilation factor of 0.2, divide by 14 cubic feet per pound of air, times our depression, 36 grains, divided by 7,000 grains per pound of water, and that gives you 6.2 pounds of water per hour that needs to be removed out of this sort of facility. Or if you want to work smarter and not harder, you plug that into the calculator and it does it for you, and you see it's 6 pounds per hour, right? So easier to go new school than it is to go old school. But if you have any sort of building like this where you want to run loads, like Nikki said, we've got the best applications engineers in the country setting up in offices in Madison, Wisconsin. And I tell you, they don't have a lot to do, but they have a ton to do. They stay busy. So Nikki brought a coffee bean storage facility in Hawaii recently where I was on the phone and I said, I want to learn more about this stuff. I'm really interested in it. And we have one of our applications engineer teaches at the University of Wisconsin in Madison. And he started talking about the difference in water acuity between green coffee beans and roasted coffee beans. And I said, forget it. I'll just go back out on there. I really just call Dan. So he'll figure it out. So a couple ways to do the storage thing. Standalone. You can use Quest or Santa Fe because it's got the analog onboard control. You don't need a remote dehumidistat. You're not going to duct it. You suspend it from the ceiling. Usually the newer storage stuff where the ceilings are all open, it makes a lot of sense to go with this route. If you're going to integrate it into the AC, you can go with the Ultra Air, which has the duct collars already attached, and it's set up for remote humidistat. I swear I'm pushing it. All right, so here's an example of a facility in Louisiana, right outside of New Orleans. This is what happened before it had a dehumidifier. You can see this line here represents relative humidity. This line represents temperature. This is 80%. And you can see how, it's, the relative humidity inside that storage facility was out of control. So they were growing mold. They had lots of microbial issues. Added a Quest dehumidifier and left the air conditioner set to a little bit lower temperature. And so you can see there's still a little bit of a struggle. The moisture is all over the place. It's up and down quite a bit. When we set the thermostat, though, to 85 degrees, what you can see is a lot more consistent in terms of temperature and a lot lower, better performance with the moisture control component. And again, as Nikki said, the nature of relative humidity is such that when we warm the air, we expand the balloon's ability to be able to hold moisture, contain moisture. So for storage at least, 80 is the absolute minimum or maximum that you want to set the cooling for. So really no point to maintain anything below 80 degrees inside storage. We do a lot of work with theaters, and I'm not going to get into this because we don't have much time left, but just safe to know that if you get a call from a theater where they're having issues because it's dank and it smells bad in there, we have the equipment and the ability to be able to go in different ways. Typically that equipment goes behind the screen or above the projection booth here, ducted into the actual auditoriums or theaters. And so there's not a whole lot of difference, I'm learning, between theaters, church sanctuaries, auditoriums, big assembly spaces, and you guys know this too, especially where we went cheap on the AC design and the mechanical that was put in place there, and we don't have the ability to operate and compensate for the fact that we're gonna, this building is gonna be vacant for some period of time, and then we're gonna rush 200 people in there, and all of a sudden we want it to be comfortable for those 200 people. That can be challenging. We can do it and do it efficiently with a lot of our larger dehumidifiers. One of the big mistakes that we see though quite often is ventilation strategy in these sorts of buildings. So there's no reason in the world why you would want to ventilate this space from usually midnight till 10 o'clock the next morning or noon or whatever time this place is showing movies or whatever time the sanctuary is bringing people in to go to church. So ventilation is the first thing to check and to affect, and to make sure that we're only bringing in outside air when we have people that need to breathe that outside air inside the spaces. And then what's great about these is you can set these up so that they run as needed throughout the day, but when you shut that ventilation off at night, at midnight, and you don't bring that outside air back on until 10 o'clock in the morning, these things dry that space out. They do a really good job overnight of keeping these folks out of trouble. Senior housing's tough because our seniors like it at a higher temperature. They're usually going to set the thermostat at 78 degrees. I mentioned the Virginia Beach project, where if you're not getting runtime and you've already dealing with oversizing with air conditioners, the best way to do that, according to Dr. Joe, is to have dedicated dehumidification. The perfect system would incorporate some energy recovery ventilator, so we could balance the ventilation. We're not working against the space conditioning system if we're using an ERV, especially for in hot, humid, or mixed humid, and then you'd have a dedicated dehumidifier. So that is kind of platinum standard, and that's the best way to go about doing this to keep everybody comfortable, safe, and healthy. Some of I mentioned my background being in LIHTC. Some of the housing and finance agencies that oversee development of LIHTC construction in apartments have started to incentivize tax credit developers for including permanent dehumidifiers. Virginia's one and North Carolina is the other. They've got incentives out there to encourage developers to use it because it solves problems, and they're grabbing a hold of it. And then lastly, what I want to talk about real quick, to circle back and reiterate something that Nikki was saying, and we get asked a lot. We got asked this morning about using a dehumidifier as a single pass, basically as a poor man's DOAS. And I have friends in the engineering industry that are like, man, what we really need is we need a poor man's DOAS, right, for small capacity ventilation loads. This was actually a set of plans for some student housing at Texas A&M. It was not our dehumidifier that was specified, but somebody sent it to me to show me how they were doing it. And essentially what they had was, they had a small capacity dehumidifier. They were bringing 110 CFM in on a single pass and just dumping it into a 4-bedroom student housing apartment. It doesn't work. We've tested it, we've tried it, people have installed it, they've been disappointed by it because it's not a DOAS. What a dehumidifier is, if you were to compare the components of that dehumidifier with a dedicated outside air system, you'll see we're missing some critical components. Well, most people say, well, why doesn't it work? What do you get? Well, what if I do it? I'm going to try it. Certainly it'll improve, right? And really it doesn't. It actually exacerbates the comfort issue and the energy component, and this is the reason why. So the example we've got here is if you were to take 100% outside air at these conditions, 85 degrees, 60%, a dew point of 70, which is not anywhere near extreme in this climate, right? So that's actually a pretty nice day down here in Florida. But if you were to take that while you're trying to maintain interior conditions at 75, 50, or a dew point of 55, 150 CFM through our 70 pint dehumidifier gives you a leave-in air temperature of 122 degrees at 14% relative humidity, but at a dew point of 60, which is not acceptable, and that's not what we want to be putting inside the space. But if we split that and we only put 50 CFM through the dehumidifier and 100 CFM we're going to return from the inside of the space, we have much more desirable conditions or temperature leaving the dehumidifier, right? So we have a leave-in air temp of 105, dramatically below that. Still have relative humidity at 60%, which is very good, but more importantly, that dew point is 50 degrees and is much more acceptable to mix with whatever we've got going on inside this apartment. So this is a much, much more preferable strategy where we've got about a third, and that would be the maximum, about a third outside air mixing with 2/3 indoor return air works really well in these systems. And so what that means is, don't do this.
You're at time.
All right, so if you want to talk about pools and spas, I've got cards down there. I'll be down at the booth hanging out. This is, people call now and they don't understand, hey, there's a bunch of condensation on the glass around my pool. Well, because it's cold outside and it's warm inside your pool, inside your pool room. The biggest thing here, the biggest mistake that we see, just so you know, is the bigger the difference between the pool water temperature and the room air temperature, the more latent capacity you need, right? So if you're, I had one of our colleagues called me about a hotel property that has pool rooms in every suite. It's a pretty interesting kind of concept. they're trying to maintain 94-degree pool temperature and 78-degree room temperature inside these rooms, right? That's a huge gap, and that's a huge load. And guess what? The dehumidifiers that they use, the commercial dehumidifiers they use inside this space isn't keeping up because it's not. ASHRAE recommends 80 degrees, 80 We'll talk about these sorts of things. Thanks for your time and your participation. We very much appreciate it.